Hello, my name is Eric Tittle, and this screencast is my contribution to beautiful code. Today, I not only want to show you how beautiful code looks like from my point of view, but I want to show you how to make beautiful code. I want to introduce you to test-driven development. In test-driven development, we don't think about how to implement something. Rather, we think about how to test it. So the first thing that I'm going to write is actually a test case. In my example, I want to write a program that converts Arabic numbers to Roman numbers. You all know them. The 1 is an I, the 5 is a V, and the 10 is an X. So how should the first test case look like? I want to assert that the result of my convert method is something. Yeah, but what to test it first? In test-driven development, we always start with the most simplest test case. In our example, this would be the smallest non-negative integer, which is just 0. Yeah, we don't have to convert much in here, it's just the empty string. And already I can run my tests. So this is the first phase of test-driven development. Test-driven development has 3 stages. This is the first one, the red stage. In the red stage, or in the red phase, I make a test and first make sure that it's red. This way I can ensure that I have a function tested that I have not implemented yet. So let's just implement this function. I make a convert method and now I can already run my tests. They compile, but they still fail because I haven't implemented the method. And now I'm in the phase of test-driven development in which I try to get as quickly as possible to the green, to a running test. So I think about what would be the smallest possible change in order to get the test run. And of course, I just return only the empty string and my test turns to green. And now I finished the second phase of test-driven development. So after red, we've got the green phase, and now we come to the refactor phase, the third one, in which I can clean up my program a bit. For example, I could rename this parameter from I to Arabic, because that's what it is. I might want to move this method up a bit so that I have first the implementation and then the tests. And after the refactoring, I run my tests again and they are still green, just to make sure that I haven't broken anything. So let's proceed with further test cases. What would be the next most simplest test case? Next most simplest test case would be to convert the 1 on I. Run the test, it's red, and I think about what would be the simplest possible implementation in order to get the test run. Now I'll try just a guard clause. When I have a 1, I return the I. I run my tests and they are turned to green. And did you notice how fast that went? I want that you mind those small steps that I take. It takes me always only just a few seconds to go through the 3 phases of test-driven development. From red to green to refactor. Again from red to green to refactor and so on. It takes always just a few seconds. Let's make the next test case. 2, for example. Again, I'm in the red phase. What would be the most simplest change in order to get that test to green? Just make another guard clause 2. And we had green again. And so on. And you see, it's really quick. I write the next test case and I do a really small step in order to get that test to green again. 3. And we are green again. So now I introduced a little duplication in here and I tried to, well, I want to resolve that. Let's think about, for example, those constants. When I return the 2, this 2 is actually nothing else than just the 1 and the 1 once more. I run my tests again, this is still green, so this still works. And so what I'm doing in here is that I actually return the same I as I have returned over here once again and then return something else to this. And the same rule applies to the line further down. When I change this, my tests still run, so I see, okay, I haven't broken anything. Now, I think about those constants over here. How could I resolve them? This actually is, we've got this actually again, because this is nothing else than the conversion of 1. Run the tests again, they are still green. Again, notice those small steps. And here we have nothing else than convert 2. Again, the tests run. And I even could go forward and do the same thing over there. My tests still run, and I see, okay, I've made things look a little bit more similar. But still those numbers in here are a little bit strange. Let's think about what that actually is. When I convert an Arabic, I write this I at the front, and then I convert the same Arabic number, but just once less. So it's like I take my Arabic number and reduce it by 1. Let's see if that works. That works. So let's make this change in the other lines too. So it works again. And now I have made all those 3 lines look almost identical. In fact, I could say that's always the case for all numbers that are bigger or equals than 1. So I could remove those other lines and I reduced my duplication and made just 1 line. But what happens when we add new test cases? Let's add the new test case for 4. This turns to red and I try to implement it. What is the simplest possible solution? As the test turns to red, we see that our current implementation doesn't cover this test case. So we need to write something new. I go for the most easiest solution. Take the Arabic, when it's 4, I return I4. So I try to run the tests, and now they are still red. And that's interesting, because I didn't consider that that the 4 is already covered by the first line, but it gives me the wrong result. So what I haven't talked about yet is that I really need to take into account the order of the numbers. So I need to check bigger numbers first. So I need to actually change the order of those 2 statements. I run my tests and they are green again. So the learning from that is that even though I did a small error, test-driven development enables me to quickly fix those errors. So it took me just a few seconds in order to get from the red to the green again. So proceed with more test cases. What would be the 5, for example? 5 is red, so now I know the order is important, so I write the bigger numbers first. I'm green again. I implement the test case for 6. It's red. And I do the smallest possible change in order to get my tests green again. It's green again. So it gets a little bit tedious, but when you have a close look, you see that what I'm actually doing is not much different from what I have done before. So at latest now, when I implement the 7, I see that the structure that I'm implementing here is quite similar to what we had before. So let's make the same change as we did before with this convert method. The only difference in here is that we now have a 5 rather than a 1. So let's replace that and see if the tests still run. They do run. So let's just change those other statements as well. Let's see. My tests still run. And the third line, let's put it in there as well. And my tests still run. So I can actually make the same change in here as I did in the line that I have written at first. I replace the equal sign by greater equals and remove those other lines, and my program still works. So now I've got this line in the middle that looks a little bit different from the other two lines. And now the question is, how could I generalize that? Of course, I need to make the middle line look the same like the other two lines. And in order to do that, I just make it look like the same. Let's see if that works. Arabic -4, and over there I change the equal sign, and so it looks quite the same, and even my program works. So my changes hadn't any bad effect on my program. So and now I've got 3 lines, the same structure, a lot of duplication, and the question how to resolve that duplication. In that I always try to separate what stays the same from that changes. What stays the same? The thing that always stays the same is the structure of the lines. I always have an if statement, a condition, a return statement, a Roman number, and then this recursive method call. And what is different? Different is always those Roman numbers and their values, the 5, 4, and 1, and so on. So let's just try to extract those Roman numbers and their values from my algorithm. How to do this? I try to do this in order to, I try to do this with map. So I write a map which goes from integer to string, and this map should hold the values of my Roman numbers. So those are the values of Romans. So I choose to take a new tree map because that is ordered, and I need to consider the way the tree map orders numbers, because in the natural order it orders the numbers always from the smallest to the biggest one, but I want to have it the other way around, so I need to provide a different comparator. Let's take the comparator reverse that orders the numbers exactly in the other way around, from the biggest to the smallest number. I've read this before. So let's populate this map with some data. Take the 1 first. The 1 goes to an I, and 4 goes to an IOE, and the 5 goes to a we. So my tests run again. They should, because I haven't changed anything at the implementation, but this way I can make sure that I have nothing broken by implementing my method. So now the question is, how can I introduce this data structure that I have just created into my algorithm? Apparently, I need to iterate over this map. So I try an for each loop. I want to iterate over the value of my Roman numbers. So I iterate over integers, value of Roman. So and I want to take this value of Roman, of course, out of my map. So take my values of Roman's map and from that the key set apparently. So and now I need to make the step from those concrete cases to the more general case. In order to do this, I take one of those concrete steps, and now what do I need to change? I have this one, and this one is actually a very specific case of a value of Roman, because this is one value of a Roman number. So I just replace this by my value of Roman, and then I return the Roman number for this value of Roman. So I need to return a value from my map, and this should be the value that I get when I convert this value of this Roman number. And then when I have converted this, I want to convert what is left from the Arabic number when I reduce it by the value of this Roman number that I have just converted. So now I run the tests again, and they still run, and even when I remove those specific cases, my tests still run. And this shows me that I have just implemented an algorithm to convert arbitrary Arabic numbers to Roman numbers. And now I can go forward by implementing all the remaining test cases for all the other Roman numbers. And I could clean up my program a bit, for example by moving the test cases into a separate test file. I could replace this initializer block by a constructor and so on and so on. But I leave those changes to you as an exercise. Just keep those small steps in mind. Test-driven development is actually not a testing technique. It is a design technique. With those small steps and test-driven development, you almost automatically arrive at a good design. And good design consists always of two parts. First, it works, and second, it looks beautiful. So with small steps and test-driven development, you make code that works, and you make code that is beautiful. Thank you for watching. This was my contribution to beautiful code. My name is Eric Tittle.